Oblique asymptotes continued. Question is, we have to find out all the asymptotes for the curve x times y minus x whole square minus x times y minus x equal to 2. Here, we have to check the highest powers of x and y. So highest power of x will be x cubed, because if we expand this, we will get y square plus x square minus 2xy. So let's write it clearly so that thing may remain clear. Y square plus x square minus 2xy minus xy plus x square minus 2 equal to 0, or xy square plus x cube minus 2x square y minus xy plus x square minus 2 equal to 0. Here, highest power of x is x cube, whose coefficient is 1, which is constant. So there is no asymptotes parallel to x-axis. Now, highest power of y is y square here. So its coefficient is x. So asymptote parallel to y-axis will be x equal to 0. This is parallel to y-axis. Now we have to find out all oblique asymptotes. So for that, we write the highest degree terms in order. So first we write third degree term. We denote it as phi 3m. So third degree term is this. Here we have to put x equal to 1 and y equal to m. So this will become m square plus 1 minus 2m. Then we write second degree term phi 2m. So second power is here and here x equal to 1. So this will give minus m plus pi. So minus m plus pi. Then first degree term. Here first degree term is absent. So phi 1m is equal to 0. Now we find derivatives. So phi 3 dash m will be 2m minus 2, or to common m minus 1. And if we find second derivative, phi 3 double dash m, so this will be just 2. And if we find first derivative of phi 2m, so phi 2m dash, it will be minus 1. Now, let's put y3m equal to 0 to get the roots or slopes of asymptotes which are real. So m square minus 2m plus 1 equal to 0. So this will give m equal to 1 and 1. So this is case of repeated root. So for that, we get the value of c by formula c square by factorial to y3 double dash m plus c times phi 2 dash m plus phi 1 m equal to 0. Now let's put the values. C square by factorial to phi 3 double dash m. So phi 3 double dash is 2. So into 2, and then plus c times phi 2 dash m. Phi 2 dash m is minus 1. So minus 1 plus phi 1 m. Phi 1 m is 0 equal to 0. This 2 will cancel out because factorial 2 is 2 into 1. So c square minus c. C square minus c equal to 0, from where we get c equal to 1 and c equal to 0. So we have got m is equal to here 1, 1, and corresponding values of c are 1, comma 0. So we can write the asymptotes by using formula y equal to mx plus c. So two asymptotes will be y equal to mx plus c. So y will be when m is 1 and c is 1. So this is x plus 1. And when m is 1, y is 0. So y equal to x. Now, one asymptote we have already found, that was x equal to 0. Let's take another question. We are given the question x minus y whole square times x minus 2y times x minus 3y minus 2a times x cubed minus y cubed minus 2a square times x minus 2y times x plus y equal to 0. We have to find out all asymptotes. So first of all, we have to check what are the coefficients of highest power of x and y. So here, highest power of x will be 4, because 1 power here, 1 power here, 2 power here, but its coefficient will be constant. So there is no asymptote parallel to x-axis. Similarly, coefficients of y power 4 will be constant. So again, we can say that there is no asymptote parallel to y-axis. So we have to find out the oblique asymptotes. For that purpose, we consider fourth power term. So let's write it as y4m. And we are going to put x equal to 1 and y equal to m in fourth power term. Only fourth power term will come from here. So we can write it 1 minus m square, 1 minus 2m, and 1 minus 3m. And phi 3m means third degree terms. So third degree terms are here only. So when x equal to 1, y equal to m, so we will get minus 2a times 1 minus m cubed. Then second degree term, phi 2m. So phi 2m second degree term will be the product of these two. So this is 1 minus 2m. So minus 2a square, 1 minus 2m times 1 plus m. Now, slopes of asymptotes are real, and we can get them by putting phi 4m equal to 0. So when phi 4m equal to 0, we will get m equal to 1, m equal to half, and m equal to 1 by 3. So these values are distinct. So it is simple to get the values of c. So let's find out the derivatives of this. So first we write phi 4 dash m. So differentiation of this will become twice of 1 minus m. Other two, here we are going to apply a product rule. So we are differentiating this and keeping other two terms intact. 1 minus 2m into 1 minus 3m. Now we differentiate this from where we will get minus 2. So minus 2 times 1 minus m square times 1 minus 3m. Then we differentiate this from where we will get minus 3 times 1 minus m whole square times 1 minus 2m. Similarly, we find its second derivative, phi 4 double dash m. So again, we apply product rule here. So this will become, if we differentiate this, we will get minus 1. So this will become minus 2 times. Other terms we can write. So Here there is slight mistake when we have differentiated this, so minus sign is already will come over here. This will become plus 2, or we can write it minus 2 inside, and then we differentiate these three terms first. So we will get minus of 1 minus 2m times 1 minus 3m minus. Then we differentiate this term, we will get minus sign minus 2 times these two terms, 1 minus m into 1 minus 3m. Then we differentiate this, so we will get minus 3 times 1 minus m times 1 minus 2m. This is differentiation of this term. Now we are going to differentiate this term also, these two terms. So this will give minus 2 times, we differentiate this, so this will become, there are two functions here, twice of 1 minus m, but it will leave minus sign because when 1 minus m is differentiated, it gives minus 1 times 1 minus 3m. Now we differentiate this, so this will give minus 3 and then 1 minus m square. Now we differentiate this term again using product rule. Minus 3, this will give minus 2 times 1 minus m times 1 minus 2m, and then here this will give minus 2 times 1 minus 3m whole, sorry, 1 minus m whole square. And we differentiate this term phi 3m. So phi 3 dash m. So its differentiation will be equal to this minus sign. This is 3m square with negative sign. So this will give 6am square. And if we find its second derivative, but it is not necessary to get second derivative of this. So phi 4 dash m can be found by putting m equal to 1, because we have got the values of m, three values, m equal to 1, m equal to 1 by 2, m equal to 1 by 3. So let's evaluate so here for m equal to 1, we find phi 4 double dash m means 1. So if we evaluate it, if we put the value here, so on simplification, we will get it 4, and that is your work. And now phi 3 dash phi 3 dash m for m equal to 1, if we evaluate, it will be 6a, and phi 2m for m equal to 1, it will be 4a square. Now, here, values of m, one thing I missed here, we had value of phi 4m as 1 minus m whole square times 1 minus 2m times 1 minus 3m. Here, this root will be repeated. So m equal to 1 more value is there. There will be 4 asymptotes because it is 4-degree term. So for repeated roots, means for m equal to 1, there is a repetition. So we can get the value of c by c square by factorial 2 times phi 4 double dash m plus c times phi 3 dash m plus phi to m equal to 0. We can put the values. So c square by factorial 2 is 2. Phi 4 double dash m is equal to 4. So into 4 plus c times phi 3 dash m is 6a plus phi to m. Phi to m, when m equal to 1, we will get from here as 4a square. In this equation, if we put m equal to 1, so we will get 4a square. So here we write 4a square equal to 0. Now we simplify. So our equation will be c square plus 3ac, each term is divided by 2, 3ac plus 2a square equal to 0, which will factorize to c equal to minus a and c equal to minus 2a. So asymptotes will be y equal to mx plus c for value of m equal to 1, first value. So this is x and c is minus a. Similarly, this is one asymptote and second asymptote will be y equal to m. M is again 1, so x, but c will be minus 2. So these are two asymptotes corresponding to m equal to 1. Now, there are other two values. One is m equal to half and another is m equal to 1 by 3. So let's evaluate. We can clear everything. So now, for m equal to half, phi 4 dash m, we have got as minus 2 1 minus m times 1 minus 2m times 1 minus 3m minus twice of 1 minus m square times 1 minus 3m minus 3 times 1 minus m square, sorry, m whole square times 1 minus 2m. Here we are going to put m equal to half. So when we put m equal to half, so phi 4 dash half, we evaluate. So it will become 1 by 4. You can do the calculation. And we find phi 3m for same value, means for m equal to half. So phi 3m is given by, remember, 2a into 1 minus m cube. So here we have to put m equal to half. Then we will get phi 3 half will be minus 2a times 1 minus 1 by 2 whole cube. So we can simplify. So this will become minus 7a divided by 4. Now, in this case, c will be given by minus phi 3m divided by phi 4 dash m. We put the values minus 7a by 4. There is already 1 minus sign. This will become plus divided by phi 4 dash m. And phi 4 dash m is 1 by 4. We put it here 1 by 4. So this will give 7a. So corresponding to m equal to half, we have got c equal to 7a. So asymptotes will be y equal to mx plus c, 1 by 2x plus 7a. Now, one more value of m is left, and that is 1 by 3. Corresponding to that also, we have to find out the asymptote. So let's evaluate the same thing. So when we write m equal to 1 by 3. So let's write m equal to 1 by 3. So we have to find out pi 4 dash 1 by 3. So here in place of m, we can write 1 by 3 minus 2 times 1 minus 1 by 3, 1 minus 2 into 1 by 3. And this term will become 0. So we can easily say that the term containing 1 minus 3m will become 0. So only one term will be there. And then we put the values. So times 0, etc. So finally, we will get minus 4 by 9. So we can say pi 4 dash 1 by 3 is equal to minus 4 by 9. Now pi 3m, here m is 1 by 3. So pi 3. And we know pi 3 equal to, we have minus 2a times 1 minus m cubed. So we put the value of m as 1 by 3 here. So we will get minus 52 divided by 27. A. Again, we find value of C. The C will be given by minus pi 3m divided by pi 4 dash m. So we put the values minus 52 by 27a divided by minus 4 by 9. So this will give here this value is negative, this value is negative, and here in formula there is already one negative sign. So there are 3 negative signs. It means minus sign will be left, and then we will get, this will become 52 upon 27 times 9 by 4 times 8. 9 3, sir. And this is 13 times. So we have got minus 13a divided by 3. So for m equal to 1 by 3, we have got c equal to minus 13a by 3. Then corresponding asymptote y equal to mh plus c will give, in place of m, we write 1 by 3h, and in place of c, we write minus 13a upon 3 equal to y, or we can multiply by 3 to each term. So we will get 3y equals x minus 13a, which is fourth asymptote. Thank you for watching.